Okay, so we're done. Okay, so that's a reference triangle, not just a reference angle. This is theta. We already said that. Okay, so we're making our trig functions. I know you know the names of them, but the reason that we're putting the names in is because we're adding the other three, which we haven't talked about yet. Okay, so sine is opposite over hypotenuse, so in terms of this reference triangle, that's going to be y over r. Cosine is adjacent over hypotenuse, so in terms of our reference triangle, that's x over r. Tangent is opposite over adjacent, so that's y over x. New trig functions. Cotangent. Cotangent is just tangent flipped over. It is the reciprocal function of tangent. So it's x over y. Secant is the reciprocal function of cosine. And cosecant is the reciprocal function of sine. Okay, so now, all you have to know is, if you know the first three, all you need to remember is how you find the second three, by which one you flip. And I don't know if this will help you or not, it kind of helps me. Obviously, tangent and cotangent go together, that one's easy. But if you'll remember that the word co, see these are all co's? Co means together. And you can't have two together, so it can't be together. It has to be together with something. So cosine has to go with something else that's not co. So it goes with secant. Sine goes with cosecant. So they each have a co. Does that make sense? So you wouldn't have a pair of two co's. That way you don't get confused and think cosine goes with cosecant. It can't, because that's two co's together. That makes any sense. All right, so all we're going to do today with the other trig functions is just identify them. We'll get to the point where we use them more, but right now we're just going to identify them. So here's how this is going to work. We're going to draw, just like we did yesterday, a terminating angle. So this says, suppose the terminal side of a rotation angle K passes through the point -3, 4. So I'm going to put a point at -3, 4. And I know it's terminating there. Now, they honestly didn't tell me which direction this goes. They didn't tell me if it was a positive angle or a negative angle. They didn't tell me if it went around 360 degrees first. All they told me was that it stops at the point 3, 4. So it doesn't matter though, because I am going to do just what we did yesterday. You're going to go from that terminating side back to the x-axis, always. Just this time, instead of just looking for the angle, we're going to draw straight down so that I form for myself a right triangle. So now, angle K is going to be the reference angle that I use right here. And because they gave me the point -3, 4, I know that this leg of this triangle is 3 units long. Now, because it's in the negative direction, I am going to put the negative sign on it. And the other leg is 4 units tall, so that'll be a 4. So what is the hypotenuse?
Oh, a 3, 4, 5.
3, 4, 5. So now because I have that, I can evaluate and find all 6 of my trig functions. So remember, sine is opposite over hypotenuse, so sine is going to be 4 over 5. Cosine is adjacent over hypotenuse, so it's going to be -3 over 5. Tangent is opposite over adjacent, so it'll be 4 over -3. And then we get to the new ones. Cotangent, you just flip over tangent. So it's -3 over 4. Secant, you just flip cosine. So it's 5 over negative 3. And cosecant, you just flip over sine. So it's 5 over 4. Everybody good? All right, so now let me scroll this up real quick so you can read the question. Okay, so now it says, suppose angle K measures approximately negative 233.13 degrees. Then they say, do the calculator values for sine, cosine, and tangent of this angle match? So let's plug it in our calculator real fast and see. So go ahead and plug in sine of, and you can put in, even though it's obtuse for right now, you can go ahead and put in negative 233.13. I got negative 0.60.
Wait, sine?
Oh, hold on. I'm in radians. Give me a second.
Are you really in radians, or is it saying you're in radians?
Oh, no, I really am.
Do it for all sine, cosine, tangent.
Just sine, cosine, and tangent. It just asks about the original 3 values. And you can just, if you want to just write them, sine, cosine, and tangent, just write them under there, you can.
Right.
Oh, I got 0.8.
Yes.
I got 0.79999. Okay. Okay, so when I did sine of negative 233.13, I got 0.8. What is 0.8 as a fraction? 4/5.
Oh, it's a fraction.
Just exactly what I had up here, 4/5. Say, so if I do cosine, what'd you get for cosine? Negative 0.6. What is 0.6 as a fraction? 3/5. So it does work. The question is, do the calculator values match the answers you got in C? They do. Now, I want you to see something though. What if we did the reverse? What if they didn't give us the approximation and they ask us to find the angle this way? I'm going to plug in my calculator inverse sine, right? Because we're looking for an angle, so I'm going to go inverse sine, and plug in 4/5. Does it give you 23.13? Nope. Why not?
Because it assumes it's
Exactly. Because your calculator, remember what we talked about, your calculator is not going to give you these obtuse angles. And it's certainly not going to give you an obtuse negative angle. Your calculator doesn't know that. Now, you can get it from here. But we would have to have been told which direction this went. And they didn't tell us from the beginning. They would have had to have told us at the beginning it was a negative, and that it went in the negative direction, and it ended up in quadrant 2. Which they didn't tell us, so I will tell you, I will give you the information on how you find those, not tomorrow, but the next day. Okay, Monday. That's tomorrow, it'll be Friday. All right, so let's go to the next page. All right, so on this one, they just did not set up a grid for you. So you can set up they didn't set up a corner plane, so you kind of set up your own. This time they tell me it goes through the point 12, -5. What quadrant would that be in?
Oh, 4.
Quadrant 4. So down here I have a point. You are going to draw from that point on the terminal side of your angle back to the x-axis. All right, so I know that this is 12, has a leg of 12. It also has a leg of -5. Anybody know what the hypotenuse would be? 13, because this is also a Pythagorean triple. What if you didn't recognize it as a Pythagorean triple? How can you find the hypotenuse? Pythagorean theorem. Alright, so now we just set up our ratios, sine, cosine, and tangent. And the new ones, which they put it in a different order. I don't know why. So just be careful and watch how they put them. Everybody okay? Any questions so far? Okay, so you try 2, 3, and 4. Now, do me a favor on 2, 3, and 4. Give me exact answers. So if you have to take a square root and it doesn't come out even, leave it as a square root. We're gonna most of what we do in trig will be exact answers and not decimal approximations.